Good evening and welcome to our today's class. We are having a conversation around access control list concepts, otherwise known as ACLs. And ACL is such an important chapter in networking because we are going to learn how to configure routers to work like firewalls. And we call this access control list, or we call it access control entries, ACEs. That is the other name for it. And so for our class today, we expect to cover the following objectives. We will explain how ACLs are used as part of network security policy. We'll explain how ACLs filter traffic, how ACLs use wildcard masks. And remember, we used wildcard masks during our last class when we were talking about OSPF, which is open shortest path first. We will also learn how to create ACLs, very, very important. And of course, we'll compare two major types of ACLs, which is standard and extended ACLs. All right. So when we finish this, and then thereafter we will configure ACLs. We look at how do you configure standard and extended, and each of them have two subdivisions again. We either have standard, numbered, and named, and we have extended, numbered, or named. So ACL is such an important concept, and it's if you don't have money to buy a firewall, then you can configure ACLs within your router, and you will have some level of security. But just as we did learn in the previous chapter, chapter 3, security is not a one-man show. It is no one can ever say that their network is secure because the smallest link or the smallest weakest link in your network is always your source of vulnerability. So there's nothing as a secured network. Either you have been hacked and you know it, or you have been hacked and you don't know it. That is the policy that we use. So what is an ACL really? So basically, an ACL is just a series of iOS commands that we use to filter traffic based on some parameters. And these parameters could include things like IP addresses, source and destination, MAC addresses, port numbers, protocol services like, Telnet, SSH, on and so forth. And so normally, by default, a router doesn't have any ACLs. So it's until you configure them and then you apply them on an interface, then the router begins to filter packets. And the filtering is either the packet will be permitted or it will be denied. All right. And so these statements are what we call the access control entries or access control list. Okay. Now, so moving forward, several tasks performed by routers normally require the use of ACLs to do the following. So one is that an ACL could limit the network traffic to increase network performance, preventing some kind of traffic. For example, in a network where, there is a group of people, probably they are students, who are streaming so much on YouTube, and yet we need the bandwidth to be preserved for office use. We could limit the voice video traffic for some time, and so that people working, doing their office work, accessing the work servers could be able to do their job. ACLs can also be used to provide traffic flow control. You could control the flow of some traffic from one part of the network to another part of the network. Obviously, ACLs provide some basic level of security for network access. You can prevent an IP address or the whole network from accessing a certain resource or a certain part of the network. ACLs could also be used to filter traffic based on some traffic type, and we're going to talk about that. And of course, ACLs could also be used to screen hosts to permit or deny access to network services. Now, of course, ACLs also provide priority to certain classes of traffic, unlike others. Okay. So like I said, two types of ACLs. We have standard ACLs and we have extended ACLs. And standard ACLs are a little bit basic because they only filter traffic based on a source IP address only. That is so worrying. That's so limiting. But to have a greater control of your network, you need extended ACLs because they filter traffic based on so many parameters, including the layer 3 source and destination IP addresses, port numbers, TCP and UDP services, and protocols. ACLs normally are only applied within layer 3, which is the network layer, and layer 4, which is the transport layer. Now, we want to check out how does ACLs operate. So the first thing that we need to talk about is we need to understand what is an inbound traffic and outbound traffic. So inbound traffic obviously is traffic coming into the router, and outbound traffic is traffic coming out of the router. Inbound, outbound. So an interface that is carrying inbound traffic, you should realize, can also carry outbound traffic, which means traffic could come through that interface into the router, but traffic could also go out of that interface, probably into another router or into a switch. And so inbound, outbound, important just to note that. Now, before I talk about, how traffic comes in, knowing how many ACLs could be configured within a router, I would like to talk about wildcard mask, but very briefly. We did mention that wildcard mask is the opposite of subnet masks. And if you are given a subnet mask like 255 to 255 to 255 to 0, you will need to subtract it from a /32 subnet mask, which is 255 on all the 4 octets. So 255 to 255 to 255 to 255. So if you subtract that minus 255 to 255.0, you'll end up with 0.0.0.255. We did that. And if you didn't do that, I mean, if you're not there in that class, then feel free to access it on our YouTube channel so that you can be able to give a reminder of yourself, a reminder for yourself. Now, there's a limit to how many ACLs that could be applied on a router interface. For example, if a router is running both IP version 4 and IP version 6, and let's say a router has 4 interfaces, let's learn how many ACLs can be configured on a router interface, one router interface running both IPv4 and IPv6 addresses. So the thing is, as you guys can see here on my diagram, we have this interface. Let's say it's interface gigabit Ethernet 0/0/0. This interface has been configured an IPv4 address 192.168.10.1/24 and an IPv6 address 2001:db8:ACAD:1:1/64. So for IPv4, we can configure one ACL for inbound traffic coming in, and we can configure one ACL for outbound traffic. For IPv6, we can also configure one ACL for inbound traffic and one ACL for outbound traffic. And that means for every interface running both version 4 and version 6 of IP, we can have up to 4 ACLs. So that is something in your exams. When I ask that a router is running both IPv4 and IPv6, a router has 3 interfaces. How many ACLs can be configured on them? Just multiply 3 times 4, because 4 is the constant here, and you will get 12 of the number. So hope that is clear. Enough. All right. Let's talk about some best practices when implementing ACLs. Why are we talking about best practices? It's because implementation of ACLs requires detailed attention and great care, because mistakes can be very costly to you as an employee, as a network admin, as a security admin, and you don't want to put your company or your boss or the employees in such a situation. Imagine if you use an ACL and you by mistake blocked your boss, the CEO of the organization from accessing the network. What a damage, you'll be fired the same day. So poor network services, troubleshooting efforts, downtime, being fired from work, those are actually demerits of poor implementation or lack of enough detailed attention when implementing ACL. So every time you want to implement ACLs, make sure you pay attention and read your organizational security policies. Very important, very, very important. So that you make sure when you implement an ACL, you're actually within the guidelines of the organization security policies. Number two, when you want to implement ACLs, first write down what you want it to do, okay? Because this is gonna help you to avoid any potential mistakes or security or connectivity problem. Normally use a text editor to edit, to write, or create and even save all your ACLs. Why? Because you're gonna need to reuse them some other time. Normally document your ACLs using the command remark, right? So like in programming, we document our code. We give an explanation of what the code does. In ACLs, also document them by trying to explain what the ACLs do, so that someone can understand your lines of ACL. Then finally, you need to test your ACLs within a development environment like Packet Tracer or GNS3 or something like that. This is going to help you to avoid costly areas within your network. Now, like I mentioned, of course, two types of ACLs that we have: standard ACLs and extended. Standard ACLs permit or deny packets based on only source IP addresses. That is very minimal protection. If you want to do more with ACLs, you're going to need to do extended ACLs, because these are going to permit or deny packets based on both source and destination IP addresses, source and destination port numbers, protocol types, so on and so forth. Now, ACLs, whether standard or extended, come either as numbered or named ACLs. And let's start with the numbering. So when we talk about the numbers, any number between 1 to 99, all right, or 13 to 1999. These are unique numbers meant for standard ACL. Number 1 to 99. If you exhaust 1 to 99, then you have to use 1300 to 1999 and 1999. Those are numbers reserved for standard ACLs while creating them. And any number between 100 and 199, 100 and 199, or 2000 to 2699, these ones are extended ACLs. These ones are extended ACLs. So one way of identifying these ACLs, if they're using numbers, if you see any number between 100 and 199, you know that is extended, and the router identifies that as well. And if you see any number between 1 and 99, you know that is standard ACL. Okay. And of course, to create them, look at this. To create these ones, you must start with the word access-list. When you say access-list, put a space and then put a shift and question mark. You will be able to see the numbering that we are talking about here. But for named ACLs, whether it is standard or extended, here use names. So from what I have already talked about, you need to already see that the numbers will limit you, because if you can't use 1 to 99, then you are not talking about standard. And if the numbers are not strictly 100 to 199, you're not talking about extended. But you realize that names can be any name. You can use a million, over a million, billions and billions of names that you can use in a router. And that's why when you want to create a number, a name, the name must be one name. They should never have a space between them. That is, if you want to create a space within them, use an underscore or a hyphen to create the space. I think the name, it is always advisable, not a must, to use capital letters to create your names, and that is for easy visibility. You differentiate your pieces of code from the name of the ACL. So for you to recognize it easily. So that means named ACLs are far better than the numbered ACLs. Remember, when creating the numbered ACLs, we start with the access-list. But when you create named ACLs, you start with IP access-list. But you must say whether it is extended or standard, and then you give the name here. Very, very important. So for named ACLs, you must indicate whether it is standard or extended. For the numbers will do the magic for you. They will differentiate the standard from extended. And so for named ACLs, you say IP access-list extended, for example, you say FTP-filter. Then your permit statements will be a permit TCP. Of course, I'm going to explain all this in the next part of this class. Now, I want you to realize that while configuring these ACLs, you might configure them with permit and deny statement, but until you put it on an interface, until you place it on some interface, it's like you recruit security guards, but until you put them at the entrances or the exits of your home or an institution, they're not gonna check on who is coming in and who is coming out. Imagine of getting the security guards and you give them a room and you let them stay inside that room and you say, I'm secure, because they're already inside the compound. You need to put them at the entrances and the exit points of your locality. All right. So when placing, and this is something I need you to pay very keen attention to. Let's say this is PC1 here, and you need to filter traffic going from PC1 going to the server here, different network. So that means traffic is going to travel all the way to R2, R3, then to the server. Okay. Now, extended ACLs are put as close as possible to the source of your traffic. Very important. As close as possible to the source of traffic. Okay. So if you're configuring extended ACLs and the source is PC1, the destination is the server, it must be put in the router that is closest to the source, which means R1. The ACLs are not put on the switches, by the way. Probably except in a layer 3 switch. So put it in R1. R1 is the closest to the source of the traffic. And you ask yourself which interface. You're going to put it on interface G00. And of course, we are going to talk about this in a while. Right? But just know it is put as close as possible to the source. The standard ACLs must be put as close as possible to the destination. Must be put as close as possible to the destination. So if the server is the destination, and the router closest to it is R3, then you're gonna want to put it on R3, and you put it on probably on G001, and of course we will look at those variabilities. Now, what I've said is only for the purposes of answering Cisco exam questions. Otherwise, sometimes you might not have control on either of the routers. You might not have control on the source of the router closest to the source, on the router closest to the destination. And that means placing of ACLs otherwise will depend on the extent to which you have control within your organizational network. All right. Maybe the destination router might not be the router that belongs to you or your organization. It might belong to the ISP, and you can't configure the ISP router because they have their own admin access to it. Bandwidth available in your network is a very great determinant on where to place these ACLs. And finally, the ease of configuration. Standard ACLs are more easier to configure than extended ACL. So the ease of configuration for someone who has been to classes like the ones I teach, you will definitely be able to, to figure out this, because we will teach you standard and extended ACL configuration. But if you go to CCNP, you will definitely learn more and more, including configurations of IPv6 ACLs. All right, so these guys are just repeating what we have said, but standard ACLs put closer to the destination, and extended ACLs are put closer to the source. Now, I want us to do one more thing. I actually want us to basically learn how to be able to configure these ACLs, and for that matter, we are